51 and 4. Okay.
Yeah, this one had a lot of variables.
This one, just looking at it, is a more, I call them like abstract ordering games because they're not really giving you exact placements. They're just giving you like proximities. So like K is before O, stuff like that. So they're a little bit more challenging. Okay. So we have a carrier delivers exactly 8 parcels. We have G, H, J, K, L, M, N, and O. No 2 parcels are delivered at the same time, nor is any parcel delivered more than once. So we're not having any repeats, and we're not having like M and N be delivered at the same time. They're all going to be delivered separately.
Okay.
I'm going to write these out just to kind of give me some reference. Okay, so let's go into the rules.
Okay.
Rule 1 says L is delivered later than H. How'd you do that?
H-L.
Yep. Not much more to say about that one. That's a pretty basic ordering one. Next one, H is delivered earlier than M.
H-M.
Number 3, M is delivered earlier than G.
M-G.
Next one, both N and J are delivered earlier than M.
So N and then J at the bottom. And like the 2 dashes for M.
Yeah, because we don't care who goes first with N and J, right? As long as they're both before N. 5th rule, K is delivered earlier than O.
K-O.
And the last one, O is delivered later than G.
G-O.
Yeah. A lot of rules.
Yeah.
I am thinking combining a lot of these rules.
Yeah.
A lot of our variables are repeating themselves, right?
Mm-hmm.
Let's look at combining them. Which 2 rules do you want to start with first? What kind of jumps out at you?
We can do 5 and 6.
Okay. How would we combine those?
Well, actually, we can put G in between K and O.
Could be. Do we care about the order of K and G?
No.
Yeah. So think about it this way. Think about overlapping our O. If we were to overlap the O, basically what happens, I don't have like an easy way of doing this. What happens is if we have 2 O's here and we're overlapping them, our lines, our chains are just going to kind of form like this, like our N and J and M. They're just going to overlap each other. So we're kind of smushing them down together to form something like this.
Oh, okay.
Do you see how like O kind of like mushes together?
Yeah.
I guess you could say.
Yeah.
It's so hard to explain this without the way that I think about it is like, do you remember those like web charts on, I think it might have been like Microsoft Word or PowerPoint or something. And if you moved something around, it was always chained to K no matter where you moved it around.
Yeah.
Kind of think of it like that. G and O are always going to be chained. K and O are always going to be chained. So if we mush them together, they're going to form this like connection between O, but we don't care about where K and J are by themselves. Like K doesn't have to go before J. K doesn't have to go before G. G doesn't have to go before K. They just both have to go before O.
So so we could do that, right?
Yeah.
Okay.
So this works.
Okay. And we can also do 2 and 3. to
Yeah.
combine.
What would that look like?
We can overlap M-G.
Yeah. So we would get
Yeah.
this, right?
Mm-hmm.
We overlap our M that just attaches G on the end.
Mm-hmm.
What else do you want to chain? I'm going to erase the ones that we've done already.
Yeah. Number 1. So we can do L. We'll have to add L.
Yeah. So if we're
Yeah.
overlapping our H, because that's what you're seeing, right? H is our
Yeah.
duplicate.
Yeah.
What happens to L is kind of like what we did with K and O. They mush together. So we're not necessarily moving our L, we're just moving our H. Does that make
Okay.
sense?
Yes.
So what happens is it kind of chains
Yeah.
off like this, like a
Mhm.
weird limb. In this case, L can go in between M and G, could be on the end of M and G. It doesn't matter where L goes with M and G because it just has to be after H.
Could you do like H-L-M-G, or would that not be like?
You could, but you're kind of preventing yourself from thinking about what if we did H-M-L-G or H-M-G-L. So these are also possibilities because we don't care where L goes. In this case, if we're just looking at world number 3, L is kind of like a floater. As long as it's after H, can go wherever it wants.
Oh, yes. Okay. I see.
The other way to think about it is like when you read it. So when you're reading this, you can't go backwards. You can only go forward like a shark. So if I'm starting at H, if H is my starting point, I can go this route or I can go this route. What I can't do is go
Back that way.
Yeah, I can't do something like that. So when you're looking at like where H can go in proximity to this, H has to be before L, M, and G. M just has to be before G. It doesn't have to be before L because it's not connected to L.
Okay.
Makes sense?
Yes. Okay.
This is some of the more difficult ordering stuff because it's so abstract. You don't have like, if H is in 2 and 3, then where could M and G go? It's much more mental gymnastics with this kind of
Right.
stuff. So let it kind of soak in. We can combine some more stuff. What else do you see?
N, J, and M.
Yeah, we have M in both places, right? I'm gonna move this over here. I'm gonna move this. Okay. So think about again, if we're just moving our M, does the placement of N and J change at all?
It shouldn't.
Right, because we're just moving that N. So those lines between N and J are just going to extend. Does that make sense?
Yes.
So basically what happens is we have H, M, G, L. We just move our M up and it becomes
okay.
like this. So N and J, the lines attaching M, just kind of extend back up to that M over there.
Okay.
So I can move these variables around so long as that chain doesn't break. So I'm going to make this a little more readable.
So the reason we're combining all of these rules together is to help us like visualize, I guess.
Yeah. So like, for example, if we're just looking at this right now, we can attach this on, but if I'm just looking at this, it's a lot easier to figure out where M is because how many variables have to go before M at this point?
So L, H, N, and J.
Not L, because if we're looking at M, so if
Oh,
M's our starting point, we can go this route, we can go this route, we can go this route. What we cannot do is go boom, boom. I'm going to go a different direction. We have to go one direction.
okay. So only H, N, and J are before M.
Yeah, we don't care necessarily the order of those, but we know that we have to have 3, right?
Right.
So it makes it a lot easier to figure out that, okay, M can't go in 3, earliest it can go is 4 now. And if I switch directions and go the other way, then I, at this point, can go, okay, well, M has to be before G. Means M can't go in 8. So M can go anywhere between 4 and 7 right now. So when we chain our links together, it kind of opens the picture up to see how restricted these variables are. Because just starting out, they didn't look very restrictive, right? We were just looking at one part of the puzzle. But when we combine them, it makes it a lot easier.
Okay.
Okay. I'm gonna erase the dot. Okay. Let's tack on our last one, K, G, and O. How could we do that?
Add K on top of like around G. And then
J. I mean G. I think you mean G.
yeah,
too.
I'm sorry, yeah.
I
and
keep
then,
saying it too.
and then I guess O at the end or something. Yeah. Uh-huh.
So you've got this part right. G is going to be before O, right?
Yeah.
But what we can do is if we place that there, we don't have to worry about G anymore. And now we're back to that original rule of K is before O. So what we can do instead of tacking K on close to G is we can tack it on to O, kind of like this. So what we did actually was we flipped our variables around to kind of make it fit that monster chain that we had, which is totally fine. We can flip our variables around when they look like that.
Oh, okay. Okay. Yeah, because we're talking about O in specific, not G, right?
Yeah. What did the rule say?
K and G being before O.
Yeah. So when we combine them, we realize, okay, 2 have to come before O. But looking at that K rule, K is delivered earlier than O. It has nothing to do with G. The only similarity between the two is the O. And so when we think about O, we have to think about G and K. But when we just look at K, it doesn't even care about G really. That's where we're looking at O, we can either go this way or this way. What we can't do is go, well, it doesn't really happen in here, but we can't go KGO. Well, I guess we could, but we have to follow our lines basically. We can't go backwards. We can only go forward.
Okay.
So that
So
was
now-
a lot.
Yeah. Now we have this big rule.
Now we have this huge rule. First thing that I usually do is count my variables and see if I've got all my variables, because sometimes I might have a floater that's not included in my rule. So I'm going to count and see if I have all my rule or my variables. How many variables do I have? 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're using all of our variables, which is nice.
Okay.
Okay. I'm going to try to teach you this one thing. I don't know if it'll help you or if it'll make it more confusing. So let me know as we go. But I find it extremely helpful when I'm going through this is what we call a web diagram, because nothing is set in stone, right? At this point, we don't really know like who's in 5, who's in 6. We don't have like our other game, T is in 4 or 5 or something like that. So what I like to do is I like to figure out what could be first, what could be last. The easiest way to do that is when we're looking at what could be first, we're looking for something that can't have anything coming before it. Does that make sense? So go ahead.
No, I'm just trying to think. Nothing coming before.
Nothing coming before. What variables do not have anything coming before it?
H, N, and J.
There's one more variable.
L.
No, because L has H coming before it.
Oh,
It
right.
has a chain attached to it.
K? Is it K?
Yeah. So what might make this a little easier for you to realize, because we can extend these lines as far apart as we want, right?
Mhm.
As if we extend that enough, you can kind of see more clearly. M does not have to go before it. H and N don't have to go before it. Nothing has to go before it. So technically K could be 1.
Oh, okay.
That's what's kind of tricky with it.
Yeah, and honestly, this is helpful because when I was trying to work the game, I wasn't given any clues, like everything was everywhere. And I'm like, okay,
Yep.
where do I begin?
Yep. So what we're going to do is, okay, if we can have H, N, J, and K be number 1, I'm going to look at each of those variables and go, okay, if that's the earliest they can go, what's the latest that they can go? How many variables have to come after it? So if we're looking at H, how many variables have to come after H?
3.
Are you looking at M,
Oh,
G, O?
yeah. I guess I missed L.
Yeah.
So 4.
So this is where it kind of goes into that whole like shark aspect. We can only go forward, we can't go back. So this is where I'm figuring out how many have to come after it. Is if I'm going forward, I'm hitting M, hitting G, hitting O. I can go back to my starting point, I'm hitting L. So 4 have to come after it. So that means at the very least 1, 2, 3, 4. H, the latest it can go is 4. So now I have this range. H can go in 1 to 4, anywhere in between there.
Mhm.
And that's going to help a lot when you're looking at questions, or even if you want it, like, I really probably wouldn't recommend diagramming full diagrams. If you realize a variable can only go in 1 or 2 places, you can put it down there. But when we're looking at something like this, H is between 1 and 4, it's a lot more efficient to kind of just figure out the range it can go in. And if you need the visual representation in a question, you can draw out that visual representation. Because then what you can realize is, well, if the question is saying if H is in 4, I know H is going to go in 4. Then I'm going to lead with what has to come after it on this side. Everything else is going to come before it. So you can have this range.
Okay.
Okay. Sure, erase half my diagram. So we've got 1 through 4 for H. What about N? Let's do the same thing for N. What's the latest that N could go? How many have to come after it?
M, G, and O.
Yeah.
3.
Yeah. So only 3 have to come after it, which means what's the latest it can go?
5.
Yep. So N has a range of 1 to 5. do the same thing for J. How many have to come after J?
The same 3, so it can only do 5, 1 through 5.
Yep. So we have a range of 1 through 5 for J. And let's figure out K, our last one that could go first. How many have to come after K?
1.
Yeah, just our O, right?
Mm-hmm.
That's the only thing that's connected to it. So what's our range for K?
It can only go in 7. 1 through 7.
That's a huge range.
Mm-hmm.
That's a lot. So essentially K almost becomes a floater in this case.
Mm-hmm.
So now we figured out what can go first. We're going to flip it and go, okay, well, what can go last?
Okay.
So what could be my 8th spot? And the way that we figure that out is what has nothing coming after it? What variables don't have anything coming after it?
O.
O doesn't have anything. What
And
else?
L or K. Is that right?
No, look at K. You're right about L because I don't have anything attached to L, right?
Mm-hmm.
Do I
Oh,
have something
no.
coming after K?
Yeah, because O is after K.
Yeah. So the only 2 variables that can be in our 8th spot is O and L. And that's because we have nothing coming after it.
Mm-hmm.
So now that we figured that out, we're going to figure out, okay, what's the other part of the range? If we know that that's the latest it can go, let's figure out what the earliest it can go is. So we're kind of flipping it. We're thinking about, okay, well, how many have to come before it? We're going to do the same thing. We're going to start at our L. How many are attached to L? How many have to come before L?
Is it only, well, is it only H or is it H, N, and J too?
No, it's only H. Because if we look at it and we're just following our direction, we go to H, we can't go anywhere else. We can't go back forward like this, right? We can't change our direction. We can only go wherever this takes us. So because nothing else comes before H, we have to stop at H.
Okay, okay.
So our range for 8, or sorry, for L is 2 to 8. Because we can have the earliest L going is 2, because H has to go before it.
Okay.
Does that make sense?
Yes.
Okay. Let's figure out O. If we're looking at our point, how many have to come after O?
Nothing?
Nothing has to come before O?
Oh, you said come before O.
Yeah.
It'd be G or K. Or N as well.
Yes. So let's break it down this way so I make sure that you're understanding it right. We can take 2 paths here, right? We can go this path or we can go this path. Those are 2 equal paths. Those are totally fine. We can go back to our starting point. What we can't do is hit another variable and then go back. So we can take this path that hits K. One variable has to come before O, at least K, right?
Mm-hmm.
If we go back to our starting point and go the other way, we hit G, we hit M, and we kind of create this new path because now we have a fork in the road.
Oh, okay.
We can hit N, go back to M,
Also
add
H.
H and J. So 6 variables have to come before O.
Okay. Yeah.
Does that make sense?
Yes. Yeah. I was getting confused on like the direction.
It can be very confusing, but I think the easiest way to think about it is we're always moving forward. And when we come to a point where we have the split,
Mm-hmm.
this is our new like restart point or something. We can always jump back to the starting point.
Okay.
So if we have 6 that have to come before O, that means we can only have O and 7 or 8. Because 6 have to come before it.
Okay. Yeah.
Any questions about that?
No.
It's a lot. Totally fine if it makes 0 sense. Because this is a lot more abstract than a typical ordering game. And that's what makes them more difficult.
Right.
Okay, I'll just erase that. Okay. Honestly, at this point, I would probably say like I would jump into the questions with this as my diagram, because what happens is with a lot of these kinds of questions, I wonder if they do it in here. Doesn't necessarily happen in here, but sometimes these questions and a lot of these kinds of web games, a lot of them will say more about the proximity of these variables. So some of them will say like which or how many variables can only go in my 5th spot. And so when I have these ranges, I can go, oh, I have N, J, K. I guess I could have M and G too in my 5th spot, but I can count what my ranges are. And so you can see it just becomes a lot easier because you have these ranges. And
So
when we go ahead.
So if you were solving this, like you wouldn't really worry about creating the worlds. Like you think you could just do it based on the spaces we've
Yeah, and I would say it takes some practice to get used to that. What I would do probably, so like question 18 says if M is the 4th parcel delivered. Okay, well, I'm just going to map that out because I have this diagram, right? It's a lot easier once I have this diagram. If M is my 4th parcel, I only have 3 spaces before M, right? How many variables have to come before M according to my diagram?
3.
So my 3 spaces up here can be anywhere from N, J, and H. And I don't care about what order because it doesn't matter in this web diagram. They're all equal to one another.
Right. Okay.
And honestly, a lot of times these questions, we can dive into the question if you want more specifically, but these questions aren't as difficult, or we don't have to solve out a full world to understand it. So if we go, okay, well, if 3 of these have to come before K, that means that, or sorry, before M, that means L is going to be on my right side. G is going to have to be somewhere before O. K is going to have to be somewhere before O. Well, actually, I could also just kind of look at my range. O is either going to be in 5 or 7 with G and K before O. And then L's kind of a floater.
Oh,
When you go into these questions, it's pretty simple. Like it doesn't take the full world to figure this out. So the correct answer to this one is K is delivered later than N. You see how I don't have to know exactly where K is or know exactly where N is to figure out this question, because it's more of what's on my right side, what's on my left side, kind of.
And I guess what it comes down to is like efficiency, with time and all. So yeah, this makes it much quicker.
Yeah, I guess that's another thing to take away is you don't have to do full worlds to answer some of these questions. It makes it easier, but you don't necessarily have to, especially if you can do a mental gymnastics kind of like this, knowing that H, N, and J are going to be somewhere in between here. And you can visualize H going into both of those spots.
Right, right. Okay.
This is a much harder ordering game, so
Mhm.
it's okay if you're completely lost.
Yeah, obviously it's gonna take time, like more practice so I can understand and like you said, do mental gymnastics.
Yeah.
Yeah.
Yeah. I honestly, when I was studying these kinds of games, these web games were like my kryptonite. Like I hated them because I couldn't do the mental gymnastics. These
Mhm.
were like the last games that I really like mastered
Right.
because they were just really difficult for me for some reason. But I would say